Hey guys, it's Duncan from 21417A VEX Robotics. I'm just here to do our last robot explanation on our over-under world's robot. So I'm going to dive right into it with the drive. So this year we were running an 8-wheeled Omni Wheels 600 RPM direct drive, and that's powered by 6 motors on the drive, 1, 2, 3, 4, 5, 6. And you can see that the packagings, we tried to keep everything compact. We have these high strength axles across the base just to make sure we have a really strong structure, nothing's gonna warp or bend, but also just to keep the structure really compact. And then we had the battery in the middle, pretty much for convenience, but we didn't have it fall out at any point in the year. Had our tank up here, also mounted directly into the C channel, so not gonna fall out or anything. And then the last part of the drive is just our sleds. So your pretty generic sleds, just angled so we could go over the barrier. We really didn't have any issues with them the whole year. So those worked really well, especially at Worlds. So that is pretty much all of the drive. So I'm gonna move on to talking about the wings. So as you can see, we are running 2 sets of wings. So we had the front set of wings, which, as you can see, they're wedged with Lexan. And we also designed these to be our secondary hang. So the Lexan can flip up, and at Worlds, if we didn't have time to do a high hang, we in theory could have flipped out these wings and just gone backwards over the barrier, and it would have just propped up the robot off the ground. We didn't use that at Worlds, but we did design these to flex up so we could do that. And while we're up here, I'm just gonna talk about these wall riders really quick. So just 2 48 tooth gears mounted on screws so they can rotate, and those are just to make sure that none of these sleds didn't get caught in any of the grooves and cracks in the field walls. Was really more important for metal fields than plastic fields, but it was just to make sure that our bowling was smooth and that we didn't get caught on anything, and we were really happy with those. They worked really well. So moving on to our second set of wings. So as you can see, we have these back wings. Also pretty standard. We used L channel just to cut down on weight with a triangle bracing of standoffs. And we use these predominantly for pushing and skills and for descoring from the match zones. So we didn't use them as much as the front wings, but they were really useful to have, and overall we're glad we put them on there. So moving on to the next system, which is the intake. So this year we were running a 1,200 RPM intake with the 1-inch flex wheels. And we designed it so it could grab these balls really nicely, hold on to them, it wouldn't lose them. And then we also had a trapdoor mech. So basically just a standoff and 2 pieces of L channel that could rotate up and down. So we would basically just be able to put a tri-ball in there and then shoot it out. And then while a tri-ball was in here, it also kind of gets stolen by other teams. Like you can see that tri-ball doesn't go out. And then we could just also shoot it out when we got to the goal. So we were really happy with how that worked out. We used the trapdoor a lot. And just to mention how this intake is powered, it's powered by chaining it to 2 motors in the back. And these 2 motors, actually we have a couple functions that these power. So as you can see, we have a lot of gears back here, between here and the sides. So one of the functions we used this for was the intake, as I just said. But we also used it in skills for a shooter. And as you can see here, we didn't take the motors off the bot and stick them directly onto the shooter. We just had the shooter mesh directly into the system on the robot. So it was pretty much just slide this in, put 2 screws in the sides to hold everything together, and then we would be good to just go for skills. So when this spun reverse, there's a ratchet right here, and it would power the shooter, and when it spun forward, it would power the intake. So we still had intake functionality during skills, which some teams who switched out their shooters did not keep intake functionality. So that was a pretty cool addition, and we liked how it worked for skills. Okay, so moving on to the third function that these motors power and kind of the whole drive. So this is our hang mech. And as you can see, we're running a high hang. This was a G tier high hang, and I'm gonna unfold it really quick. So during a round, Well, before I unfold it, let me talk about the storage. So as you can see, it's packaged up right now. So we have the strings tucked in up here under the pneumatics, and we decided to do that so we didn't have to have a active ratchet, and also we had some a little bit of friction on here, so it wouldn't have worked super well for us to have it spooled and then unspool. So we just tucked the strings in here, and then when the cylinders fired, they pulled the strings out, and that worked really well. We didn't really have any issues with that. One issue we did have initially was this would flip out early sometimes, and our solution to that was these two Lexan pieces here. So as you can see, that keeps it from flipping out, and I can even like lift the back of the robot by those. So that kept it in really nicely. There was like one round at Worlds where this tower got loose and it flipped out early. But other than that, we didn't have any issues with that. And the way this works is basically when we were ready is just, I don't know if it has enough rubber banding. We would just flip it up and everything would flip out. And as you can see, these Lexan pieces, they tucked into the sides. All the string came out really nicely. And then we could go over with our lineup here. And we had these two standoffs, lines with Lexan funnels to just make sure it got on. And that gave us a really wide range of tolerance that we could still hit the pole and still hook on. And then we just had a standoff in the middle to hook onto everything. And then we could just drive over. And as you can see, it clips on. Let me take that off. And then basically, you want to bring the camera over here. So the system after we hooked on is a PTO. So this whole shaft shifts over. This gear on the side engages with the drive. This gear on the side engages with the drive. And then this little pinion in the middle engages with the intake. So we actually had all 8 motors on the hang. So we would spin it over. It's a little low on pneumatics right now. And then it was just drive forward, and that worked really well. We didn't really have any issues with it. We had the winches as small as we could get to get as much torque as we could get. And it was pretty fast, worked well for us. Didn't really have any issues with it. And we had it held up by a ratchet on this side, just to make sure that it didn't slip off or anything. So we were really happy with how that worked. So moving on, that's pretty much all the systems of the robot. So I'm just gonna move on to the coding on like a 20,000 foot overview. So this year we didn't use odometry or anything. You can see there's no tracking wheels. So what we used instead was just straightforward PID. And so it's pretty much your general check angle, make sure you're driving the right distance. And then one thing we also experimented with was just using PID for curves. So it would pretty much, the robot would just check its angle in proportion to how it was driving forward. And it would just do a nice curve. And we had some variables we could tune to adjust how steep the curve was, what the ending angle was. And as you know, it's not the best idea to just do PID curves because you don't exactly know where the robot is and you can accumulate a lot of air. So to give us a general idea of where the robot was, we had a couple things. So we had distance sensors. So we had one on the front to sense the bar. So we had one on the front to sense the bar. So it would stop the robot and it would touch the bar for wind point. That worked really well. I don't think we had any crosses at Worlds. And then we had one on the back. So similar idea, it would sense the barriers near the ground. And basically we could just use that to tell the robot how far it was from the barrier. And then we had the angle using these inertial sensors. So we could kind of get a rough guesstimate of where the robot was on the field and then move it to the position we wanted next. And then one last thing we did, which is kind of helpful for this year's game, was whenever the robot hit the goal, that would kind of be a realigning point for the auton routine. So using that, we were able to produce some fairly accurate, very repeatable auton routines. So that was what we were using to move the robot around. It worked really well. I don't know if it would work well in other years because you're not really resetting against a goal or something, but we were happy with it. Okay, one last thing we're going to talk about, not pertaining to this robot. So we basically for Worlds rebuilt the whole robot, drive base and everything, just so we would have a separate robot for Worlds that we could build at the same time as our other competition bot. So after we took our old robot apart, we used its drive base to basically just experiment with stuff before Worlds. So as you can see, this is our old drive base, pretty much similar packaging, to the other robot, high strength axles, 6 motor, 600 direct. Has the traction wheels in the middle, which we switched for Worlds. But this was our under 6 inch robot prototype. And really the only kind of different thing on this robot that really separates it from any other robot is the intake. So as you can see, the intake, we used the old Omni rollers instead of the flex wheels, just to get as low profile as we could. And this is a 6,000 RPM 2-motor intake. So let me rev it up. So even though it seems like it's spinning very fast because it's a smaller diameter, it's spinning about equally as fast as this on
about 1,500 RPM equivalent.
Yeah, about 1,500 RPM equivalent. But as you can see, there's a wedge on the front. So the idea was that we could come in, and you can see that went right under the intake of our other bot. And we also have the same truck door mech and everything. So actually, originally this intake was on this bot, but we just decided to switch it for Worlds, and then we could go and score that. So that is our prototype bot. I think that's really all we have to talk about for the over-under season. We had a lot of fun. It was nice seeing all the teams at Worlds. And we just wish you all the best of luck in the next season.